query your data, both of those query languages are actually natively implemented inside M3 Query. So you can just point your Grafana a data source straight in M3 Query, and that's how you go get your data out. So at a 30,000 foot view, that's really, M3. It's really, the ingestion, the storage, and the querying of your metric data. And there's really three main components at a very high level. Go to the next slide here. Cool. So a little bit more about the project and its origin. So it was built at Uber and built in open source GitHub from day one. So the first check-in for the project was April 2016, almost 5 years ago today. And we've been developing the project in open source ever since that time. And some of the reasons why we even built M3 in the first place, there's really four main properties we're going for here. The first one was large scale. So having a system that is able to handle some of the largest monitoring workloads in the world. So, and we've proven that out to handle billions of data points written and read per second, while also storing tens of billions of active time series. We also wanted the system to have really high reliability. So, there's not only replication built in, but fault tolerance. So your replicas can be put in different fault tolerant zones, such as different cloud AZs or racks inside a data center. And all of this data is highly consistent. So every read and write in and out of the system is done with quorum. So 2 of 3 copies have to succeed for that write or read to be called a success. And what that really means is that if you lose a single node or if you lose one of your fault tolerant zones, you won't lose your consistency along with that. The third property is really fast performance. So we're really optimized for really extremely fast reads and writes in and out of the system. Because of that, all of the time series data, as well as the metric index, is all both kept in memory and on local disk inside M3DB itself. There isn't a concept of storing the historical data in an object store or anything like that, because we're really optimizing for performance here. And the last one here is cost efficiency. So we wanted to make the system fairly efficient, and that's part of the reason why we built a custom time series database. And that time series database has highly optimized compression algorithms for all the data that's in it. So you can actually store these large swaths of data without using a lot of hardware. And even though it was optimized for all of these properties like large scale and high reliability, the beauty of M3 is that you can start with a really simple 3-node cluster and start with a really small use case and scale that up horizontally all the way up to the largest use cases in the world, as you'll hear in some of the talks today. So yeah, at a high level, those were the main design principles behind M3 in the first place. And I will now hand it off to Matt and Rob to go through some of the updates we've had since the last community meeting.
Great. Thanks, Martin. Hi, everybody. For those of you who don't know me, my name is Matt Way. I work at Uber on the M3 team. So just wanted to give everybody a quick update about what's new with M3. There's been a lot happening lately, and even more behind the scenes for those of us contributing to the project. So wanted to bring some of that to you folks so you can have an understanding of what's been going on. The first thing is we have a brand new website. If you haven't taken a look yet, please check it out. It's got lots of really great information on it. And that paired with the documentation, they're really great getting started guides and overviews of the components. And, it's geared toward folks who are either starting to become familiar or interested in the project, or for those of us who work on a regular basis and just need some good reference every now and then. So take a look at it. It's completely revamped. It looks really great. And if you have any feedback, obviously, please let us know. We'd be happy to hear it. There's also a new contribution guide. We really encourage folks in the community to get involved with the project. We welcome all contributions, especially for use cases that we may not be super familiar with or we may not experience in our day-to-day lives. So feel free to take a look at that, and if you have any questions, reach out. But we really look forward to folks in the community getting involved. The two sort of big updates in terms of where we've been milestone wise would be, we just officially reached 1.0 status. And what that means for us is that we've established a new sort of checkpoint in time where we've formally established compatibility guarantees. We've blessed the project as being ready for production use, although we've been using this in production for quite some time, obviously. But there are a lot of really neat features and whatnot that are available there, and we'll talk about that in a couple slides later. And then also we, in true iterative fashion, have already released a 1.1.0 with some minor updates on top of that. We have a pretty pretty consistent release cadence as far as the project goes, and we like to push updates, as soon as we've validated them and vetted them for production. So that's a quick high-level view, but let's dig in a little bit more to 1.0. So if we look at where we've been over the last 2 years, because this has really been a pretty big journey. There's been a lot of work that's gone into this project. Just in the last few years, it's been 1,500 commits, about 70 releases. There have been 60 contributors involved. So this is a really large amount of engineering work that has gone into this project. Obviously, there's even more before that, but the last 2 years, I think, we've seen a lot of ramp in getting prepared for 1.0. In particular, we've focused a lot on performance, especially for Uber scale, for other folks who have larger deployments. Having the best performance possible is really important so that we can handle all of the data that we need to for our infrastructure. In addition to that, we have a lot of improvements, just quality of life or new features that we've implemented across like all components throughout the stack. So whether you're particularly interested in querying or whether you want to make sure your nodes are bootstrapping as quickly as possible, all of those things have seen a lot of love as part of the push for 1.0. And then, like I mentioned earlier, we have a lot of activity that goes on behind the scenes for building the software, and the output of that is we have pretty consistent, incremental, and frequent updates. So look forward to seeing a lot of minor updates as time goes on. If you're interested in understanding how that affects you, like I said earlier, check out our compatibility guide. We'll be following this moving forward to making sure that, for folks who have active deployments, they don't want to change their configs. They just want to drop in, update, and everything. You'll know whether or not that a given release will work for you just out of the box. Let's take a quick look at 1.1.0. Oh, actually, some quick additional details about this. So, like I mentioned, efficiency has been something that we focused a lot on, and I already mentioned the bootstrapping bit. But these are things that actually make a really big difference to us, especially at Uber and to other folks who have larger clusters. Just because the longer it takes your clusters to become operational and to start serving reads, that's more time that it takes to potentially adapt to incoming load or to recover from some sort of issue that you're seeing. In a similar vein, as far as reliability goes, we have a lot of new knobs for limits as part of 1.0. Things like database limits for ensuring that your database doesn't get overloaded by a huge number of writes or reads. Also, improved cluster repairs for when you happen to get into a situation where some of the nodes in your cluster need to repair their data. And then lots of just overall hardening of components to make sure that all the bugs that we've seen along the way and just like all the general good sanity things of how the cluster operates, everything works as expected, and we've sort of filed down all of those sharp edges that we found over the last couple of years. Feature-wise, we've added quite a few, and this is by no means exhaustive, but just for a quick example, we now have multi-zone and multi-region support. We have preliminary support for out-of-order writes and cold writes. We have invested a pretty substantial amount into kube support. There's been a lot of work done on the query side, both in terms of like PromQL and Graphite querying. So there's been a consistently increased support in terms of the number of functions, the performance of those functions and stuff for those of you who lean on our query tier quite a bit. And then for advanced use cases, we now support writing protobuf messages in M3DB. This is something that we continue to, will expand as time goes on and as use cases require. And then on the more meta level, there have just been better tests. We've introduced a lot of tooling improvements for those of us who are contributing to the project and for those of us who are responsible for operating this on a daily basis. So just general quality of life improvements there as well.
Yeah, awesome. Awesome. Thanks for walking us through that, Matt. I thought I'd jump in and kind of look at the like a deep dive on some of the 1.0 and 1.1 changes that we have. So with 1.0, yeah, this was like we've obviously as a project been extremely cognizant of breaking changes, and the file format has always and will continue always to be backwards compatible, and the majority of the time we also ensure forwards compatibility. So if you upgrade and then you need to downgrade again, that all works nicely. And so having said all that, 1.0 was one period of time where we wanted to take the time to actually clean up some of the config and make the config much simpler, since the config is a complex beast. Just given the extreme set of features that kind of M3 does look to support, and especially I think other projects out there in the landscape obviously don't support aggregation or real-time streaming aggregation of metrics, and so there's obviously along with that and then several other features that kind of M3 supports that kind of contributes to this explosion of config. So anyway, with 1.0, we simplified the config as much as we really could, and also added the ability for the limits that we had in place to be much more user-friendly and configurable from config. But it did introduce some breaking config changes to, so you'll do a one-time update of your config to match the 1.0 syntax. And the file format, as I said, is all backwards and forwards compatible, as it has been for all historical time in terms of development in the open source world. And so as Matt kind of mentioned, a whole bunch of performance work, documentation and guides, and the new compatibility guide went out. With 1.1, further bootstrapping improvements are there. Most folks see less than a few minutes for bootstrapping nodes now. In terms of the coordinator and query, there was some further enhancements for high volume carbon and graphite, more extensive graphite query features, as well as more support for high volume carbon ingestion. And you can also now get that latency breakdown that you have in Prometheus Remote Write of the data point that's coming in relevant to time.now and how far in the past the data points that you're actually writing into the system are. We also just generally have a whole bunch of quality of life improvements, as mentioned as well. And the getting started guides are now finally well fleshed out for both Kubernetes and binary deployments. Gives, if you wouldn't mind progressing, next slide. I wanted to kind of call out that some of the major work I think that's gone into the project in terms of making it accessible to more and more folks is obviously the compatibility and automation around running M3 on Kubernetes in general. The M3DB operator is has a lot of months and years operating clusters now in the size of hundreds of database nodes with 3 replicas of data that are typically spread across multiple zones in a region, so they're resilient to zonal failures. As Matt had said previously, there's the ability for remote fan out from the coordinators, so coordinators can be aware of other coordinators and also do cross-regional queries of data. The M3DB operating as it is available today and is now actually just much more powerful and makes the experience of running M3DB in general on Kubernetes, even with these really large clusters in production, quite robust and resilient. You can also now manage updating entire clusters using to a new database node image. It's as simple as updating the cluster spec and then annotating which stateful sets you want the operator to move through and automatically update. I do suggest using v0.13, which is the latest there, since there was, if you wanted to upgrade all 3 replicas at once, there was 1 or 2 bug fixes between 0.12 that went in. So I definitely, I would, if you want to use that feature, that upgrade feature, I'd be using the latest there, but it is quite a powerful feature and worth checking out. The default pod management policy for stateful sets is now parallel. So when new pods are added or pods are you're manually deleted if you're downsizing, all of those are recreated at once. So yeah, it really allows for a much managing these larger clusters is much more straightforward now. And you can do some pretty wide sweeping changes and have the operator kind of roll out a lot of them for you. Yeah, thanks, Gibbs. That's us.
Yeah, thanks, Rob. In the last 2 minutes here, I'm going to quickly go over a couple of reminders and ground rules for the rest of the day, and then reveal the prizes that I'm sure everyone is anxious to see. So just a couple of reminders. As mentioned earlier, we do have a Slack channel for the day inside the M3 Slack, so please join that if you want to be part of the discussion with the other attendees. It's M3-day-2021. Another reminder, so you should see a Q&A box on the bottom of your Zoom window, and that's where you will ask any questions for speakers during the sessions. Speakers will, you can ask the questions throughout the session, but the speakers will not answer the questions until the end of their presentations. Another thing, raffle prizes will be announced at the end of the day during the closing remarks, so the last 10 minutes of the event. And then finally, if you want to post anything about the day, make sure you use these hashtags here. And finally, the event is being recorded and will be shared out after. So if you're not able to attend all of the sessions, no worries. You can always watch the recordings afterwards. And then if you are interested in attending the workshop, it is going to be starting at 12 p.m. Pacific time on Zoom, 12 to 1. A couple prerequisites here that have been sent out before, but just make sure you have Docker Desktop and Docker Composed and downloaded. Also, we'll review everything at the beginning of the workshop too, but just high level of kind of the capacity that is expected for the different versions of the workshop. And then also, in order to kind of follow along with everything and make sure you're in sync with everyone else, it'd be great if you could join within the first 10 minutes of the session. And finally, the raffle prizes. Winners will be randomly selected at the end. In order to win, you have to have RSVP'd and also have attended at least one session throughout the day. So we will announce this at the end, and then we'll be in contact with everyone at the end who were the winners. So yeah, that's basically it. And now we will move on to YY and Nick from Databricks to give their